The California Department of Water Resources has proposed an ambitious $5.2 billion plan for the site's reservoir to solve the dual problem of perennial flooding and water shortage in the state. The site's project authority explains that the project is a surface storage project involving a 1.5 million acre-foot off-stream surface storage reservoir located in the Sacramento Valley, west of the town of Maxwell. The proposed reservoir's conveyance facilities would include using existing Tehama-Colusa Canal and Glen-Culsa Irrigation District canal diversion and conveyance facilities, plus a new diversion and discharge pipeline. The project would pump 470,000 to 640,000 acres-feet per year of the winter flood flow from the Sacramento River upstream of the Sacramento-San Joaquin River Delta through existing canals to an artificial lake built 14 miles away. This mind-blowing construction and engineering project has already started and is taking shape faster than we can imagine. Today, we will explore the details of this mega project. Why is the project necessary? What are the challenges in undertaking such a monumental project? We will also discuss the controversies delaying this grandiose plan to solve California's decades-old water crisis. As we all know, California is a land of paradoxes, where communities simultaneously face the dual challenge of droughts and floods. This constant water crisis is no stranger to headlines, with severe droughts and devastating floods making the news all too often. How can a region experience both extremes of water scarcity and abundance? The 20th century witnessed ambitious efforts to harness water for agriculture and urban development. The construction of dams and reservoirs, like the iconic Hoover Dam and Shasta Dam, sought to tame the rivers and bring water security to California. However, this relentless quest for water had its consequences. As water was diverted for human needs, the delicate balance of natural ecosystems was disrupted. Aquatic habitats were compromised, and fish populations dwindled as river flows were altered. This means the government had to come up with an even better solution. In the 1950s, the State Water Project, SWP, the predecessor of the site's reservoir, was California's answer to the seesaw effect of droughts and floods, aiming to secure a stable water supply for the state's growing needs. The plan had a network of dams, reservoirs, aqueducts, and pumping stations stretching across the vast expanse of California. These engineering marvels were strategically placed to capture and store water during the wet season, ready to release it during the dry times. Over the years, the SWP has been a lifeline for California's agriculture, urban centers, and industries. But you know how it goes. With great achievements come great challenges. The SWP faced the tough job of dividing up water among various sectors, leading to water disputes and conflicts. Then there's the fact that the SWP's dams sometimes affected the natural flow of rivers, impacting fish migrations and aquatic habitats. This meant the project needed a desperate upgrade. Introducing California's new $4 billion mega reservoir, the site's Reservoir project. You see, water management involves a complex interplay of collection, storage, distribution, and allocation of water resources to cater to the diverse needs of agriculture, urban centers, industries, and the environment. While these practices aim to balance water supply and demand, they also contribute to the cyclical pattern of water scarcity and excess that characterizes California's seesaw effect. One of the contributing factors to this seesaw effect is the limitation of storage capacity. Although impressive, California's reservoirs and storage systems need more space to hold water. During periods of heavy rainfall, when nature bestows its bounty, the state's reservoirs get filled to capacity, and the additional water flows downstream or is directed into the ocean. Consequently, much of the precious water received during the wet season goes untapped, unable to be effectively collected and stored for future use during dry spells. This inefficiency in storage perpetuates the cycle of droughts when water becomes scarce again. Hence, the site's Reservoir project was created to solve all these problems. Positioned as an off-river reservoir, it ingeniously captures and stores excess water during the wet season, boasting an impressive storage capacity of over 2 cubic kilometers. Think of it like a natural piggy bank, saving every precious drop 4 times of need. So, when the dry spells strike and water demands escalate, the site's reservoir springs into action. It releases its meticulously stored water precisely where and when it's needed most. It also considers the delicate balance of our ecosystems and wildlife by carving out space for environmental water releases, preserving habitats, and supporting the natural world we cherish. This instantly resolves the 2 major issues the SWP had. Better yet, the site's reservoir is not a distant dream. It's well on its way to becoming a reality. The groundwork and auxiliary projects that will pave the way for the main project construction started in 2022. The reservoir and artificial lake construction is scheduled to start in 2024. The entire site's project plan is anticipated to be completed in 6 years. The cost will be an eye-popping $5.2 billion when all is said and done. And now that we've unveiled the brilliance of the site's reservoir project, let's take a closer look at the ambitious undertaking of building this engineering marvel. The process of the project is just as fascinating as the project itself. After a thorough evaluation, the Sacramento Valley was chosen, a narrow valley with cliffs and hills, ready to be transformed into a vast water storage haven. The heart of the operation lies in the construction of the dams. The main dam, aptly named the Site's Dam, is strategically positioned to block the valley's flow, creating an expansive impoundment area. Supporting dams will be constructed along the valley's edges, ensuring no water seeps through gaps and guaranteeing the reservoir's waterproofing. Once the dams are in place, the ground transformation will start. The valley will gradually flood, and the reservoir will begin to take shape. During the wet season, the reservoir is effortlessly filled through natural runoff from the surrounding catchment area. The dam gates can then be controlled to regulate the water inflow during heavy rainfall events, ensuring a steady and precise rise. The site's reservoir project also boasts hydroelectric generators, which we can all agree is an extra sprinkle of innovation. This makes it ready to spin into action when water is released. This adds a sustainable touch and reduces the net energy cost of pumping water into the reservoir. The project also incorporates state-of-the-art fish screens and passages to safeguard aquatic habitats and migration patterns. These thoughtful measures ensure that fish can navigate past the reservoir unobstructed and continue their natural journeys. Moreover, a portion of the stored water is allocated to environmental needs, maintaining stable river flows downstream to support habitats and ecosystems. With a reliable water supply, the reservoir can fuel California's agricultural engine, fostering thriving farmlands that contribute to the economy. Moreover, stable water resources can attract businesses, encouraging industrial growth and job opportunities. However, the economic benefits must be weighed against the potential impacts on consumers. Critics argue that the project's financial model will force water agencies to adjust water rates to recoup costs. While this ensures sustainable funding, it challenges some households and water-intensive industries. Striking a balance is crucial to avoid undue burden on vulnerable communities while maintaining a fair financial model. What do you think of this ambitious project? Well, tell us in the comments below. Thanks for watching, and please do like, share, subscribe, and remember to hit the bell icon. We'll see you in the next video.